these are the notes for lesson 7.1, nth roots and rational exponents. In chapter 7, we're going to look at roots and exponents and look at their relationship and how we can move between roots and exponents. There's a relationship that helps us to simplify using those relationships that they have. So I want to look first at the square root of 4. We know that the square root of 4 is 2 because 2 squared is 4. The other way we can think of this is underneath the square root, 4 is 2 times 2. So therefore 2 squared is 4. So what is the cubed root of 8? The cubed root tells us we have to have something to the third power. So if we look at the cubed root of 8, can be written as 2 times 2 times 2, because we know that 2 to the third power equals 8. So the cubed root of 8 is 2. Because if we multiply 2 3 different times, it will give us 8. So if you notice, there's a relationship between the radical and the exponent. If you remember from chapter 5 when we first looked at radicals, the whole thing here is called a radical. Now in chapter 5 we just looked at square roots, so that was if there was no index. So this is our index right here, the number outside of the root. And if there's nothing written, we know that it is a 2. But if there is a number, again, that's our index. Now x can be raised to a power, so we're going to call that e, which is our exponent. And we can rewrite our radical as an exponent. So what we're going to do is the exponent becomes our numerator, and the index becomes our denominator. So it's going to be exponent over index. So e over I. So whenever we see a radical, we can change that into exponential form. So let's look at some examples. Example 1 says to rewrite the expression using rational exponent notation or radical notation and evaluate. So for part A, we have the square root of n. Again, we know it's a square root because there's no number outside, so we assume that it's 2. So if we have a 2 outside of our radical, our n is to the first power, because again, there's nothing written. So again, we're going to take the exponent over the index. So this is going to be n to the 1/2 power. For part B, same type thing. N is raised to the first power, only this time our index is 3. So again, we leave our n the same, and it is our exponent, so 1 over our index, which is 3. So n to the 1/3 power. I'm going to skip over to part D. So now we have n as our index. Again, x is raised to the first power because there's nothing written. So this is x to the 1 over n power. Let's go back to C. We have the 4th root of 81. So this is the same as saying 81 to the 1/4 power. Now I want you to think about 81 for a second and the 4th root. We want a number that we're going to multiply 4 times to get 81. So this is going to be equal to 3 because 3 times 3 times 3 times 3 equals 81. For part E, if we're raised to the 1/2 power, again, the top number is our exponent, so this is 4 to the first power, and the denominator is our index, so this is going to be the square root of 4 to the first power. 4 to the first power is just 4, and we know that the square root of 4 is 2. So for part E, the answer is 2. Part F, we have 8 to the 1/3 power. Again, 1 is our exponent, so we have 8 to the first power. And the denominator is our index, so that's going to be the cubed root of 8 to the first power. So this is the cubed root of 8. Again, we want to think of this as what number are we going to multiply 3 times to get 8? And that's going to be 2 as well. So again, we can flip back and forth between radical and exponent form in order to simplify expressions. For example 2, we are evaluating without using a calculator. So again, we're going to show the manipulation moving back and forth between radicals and exponents. So for part A, we have the cubed root of 8. Again, we want to think of what number are we going to multiply 3 different times to get 8, and that's going to be 2, because 2 to the 3rd power is equal to 8. For part B, we have the cubed root of -8. Notice that we have an odd radical. That is going to be very important in just a minute when we look at our next example. So we have the cubed root of a -8. So again, we're thinking about what number are we going to multiply 3 times to get -8, and that's going to be -2, because we know that -2 to the third power is equal to -8. Now we're going to skip down to part D. We have the 4th root of -16. Notice we have an even index. So we are looking for the 4th root of -16. So we're looking for a number that we multiply 4 times to get 16. Now if you think, we know that 2 to the 4th power is a positive 16. And we know that if we have a positive or even power, we're always going to have a positive answer. So if we have an even radical, we know that our answer should always be positive. So this is going to be no solution. Because again, if we have an even power, we'll always get a positive answer. So there's no way that we can get a negative answer. Let's go back up to part C. Now this is the 4th root of positive 16, which we just found in part D. So we know that 2 to the 4th power is 16. So the 4th root of 16 is 2. Now if we move down to part E, we have 4 to the 3/2 power. Again, if we have a fraction as an exponent, we can change that into radical form so that we can then simplify. So we know that our numerator is going to be our exponent. So this is 4 to the 3rd power. We know that our denominator is our index. So this is going to be the square root of 4 to the 3rd power. Now we know that 4 to the 3rd power is 64. So we're looking for the square root of 64. So what number times itself will give us 64, and that is 8. So again, being able to change to radical form can help us simplify and not have to work with those fractions anymore. Part F, we have 4 to the 1/2 power, all that raised to the 3rd power. Now again, the 1/2 power, our numerator is our exponent, so this is 4 to the 1st power, and it's the square root of that. Again, our denominator gives us our index, and all of that is raised to the 3rd power. So the square root of 4 we know is 2. 2 to the 3rd power is 8, so our answer is 8. For part G, we just want to change this into exponent form. So we know that x to the m is our exponent, n is our index, so this is going to be the same as x to the m over n. And there's nothing else that we can simplify for that one because we're using variables. For letter H, we have 8 to the -2/3 power. Now what we can do here is I want you to think about your exponent rules that we've talked about. When we have power to a power, we have to multiply the exponents. So -2/3 power, we can rewrite this as 1/3 to the -2 power. Because we know that 1/3 times -2 is -2/3. So we can split apart using our exponent rules that we've talked about before. Because now 8 to the 1/3 is the cubed root of 8, and then all of that is raised to the -2 power. Now we know that the cubed root of 8 is 2, so this is 2 to the -2nd power. We know when we have a negative power, that gives us our reciprocal, or we flip it. So this becomes 1 over 2 squared, and we know that 2 squared is 4, so this is 1/4. Letters I and J, we're going to do the same type thing. So 16 to the 5/2 power, again we can split apart 5/2, and that's 5 times 1/2. So this is 16 to the 1/2 power, and all that raised to the 5th power. 16 to the 1/2 power is like saying the square root of 16. The square root of 16 is 4, so this is 4 to the 5th power, and 4 to the 5th power is 1024. And last one, letter J, we have 64 to the -2/3 power. Again, we're going to split it apart. So we have 64 to the 1/3 power, and all of that is raised to the -2 power. 64 to the 1/3 is the same as the cubed root of 64. The cubed root of 64 is 4, so this is 4 to the -2nd power. Again, a negative exponent says to flip, or you do the reciprocal. So this is 1 over 4 squared, and we know that 4 squared is 16. So this is 1 over 16. The second part of section 7.1 is solving equations with exponents and radicals. If you remember from chapter 5 when we looked at square roots and exponents, we know that to get rid of a square we would take the square root. So the same thing is true with any exponent or root. To undo an exponent, we have to take that root. To undo a root, we take that exponent. So for part A, we first want to get our variable all by itself on one side of the equal sign. So we have 5y to the 4th equals 80. So the first thing we want to do is divide by 5 to get y to the 4th all by itself. So we have y to the 4th equals 16. So again, to get rid of exponent of 4, we're going to take the 4th root. And they essentially cancel each other out, because if you think about our exponent rule, this would be y to the 4 over 4, and 4 over 4 is just 1, so that's like getting y to the 1st power. So again, whatever we do to one side, we also have to do to the other side as well. So we're going to take the 4th root of 16. So what number times itself 4 times is going to give us 16, and that's 2. Now I want you to notice we need to keep track of whether we have even roots or odd roots. Now if you remember in chapter 5 again, when we had square roots, that was an even root, and we always had to look at both cases plus or minus. So whenever we solved, we always had plus or minus. Whenever you have an even root, you have to make sure you include the plus or minus. If we have an odd root, you don't have to include the plus or minus. It's just whatever answer you get. So our answer here, y equals plus or minus 2. And again, whenever we have even roots, we must include the plus or minus in our answer. We're going to move over to part C. Notice we have a 5th root here. So again, to get rid of a 5th root, we're going to raise it to the 5th power. Again, that's going to cancel out that root. So we're going to take this whole thing to the 5th power. Again, whatever we do on one side, we also have to do on the other side of the equal sign. So we're going to raise 2 to the 5th power as well. So these cancel out. We're just left with x plus 1 equals 2 to the 5th power is 32. To get just x, we're going to subtract 1. So x equals 31. Again, since we have an odd root, we don't have to worry about plus or minus. Our answer is just x equals 31. For part B, we have x plus 1 all raised to the 3rd power equals 2. Again, we want to get rid of that exponent. So to get rid of a 3rd power, to get rid of that exponent, we're going to take the cubed root. And again, whatever we do to one side, we also have to do to the other side. So if we take the cubed root on the left-hand side of our equal sign, we are just left with x plus 1 equals the cubed root of 2. And then we just need to solve here, so we need to get x by itself, so we're going to subtract 1. So x equals negative 1 plus the cubed root of 2. Now the cubed root of 2 can't be simplified at all, so we're just going to leave that as is. So again, x just equals negative 1 plus the cubed root of 2. And again, notice we have an odd root. We took the cubed root, and 3 is odd. So we don't need plus or minus. It's just negative 1 plus the cubed root of 2. For part D, notice that our square, there's other things around it. So we need to isolate our exponent or our root first before we can take the square root or the cubed root or whatever we need to do to get rid of the root or the exponent. So the first thing we want to do is add 7 to both sides. So we get 4 times 2x plus 4, quantity squared, equals 16. Next, we're going to get rid of the 4. It's multiplied by this quantity, so we're going to divide it to get rid of it. So we have 2x plus 4, again that's squared, equals 4. Now again, to get rid of a square, we're going to take the square root. Whatever we do to one side, we also have to do to the other. So we have 2x plus 4 equals, now notice we have an even exponent, so we have to include the plus or minus. And the square root of 4 is 2, so we get plus or minus 2. So we can break this into 2 different equations. We have 2x plus 4 equals 2, and 2x plus 4 equals negative 2, we can solve them each separately. So the first one, we're going to subtract 4 from both sides. So 2x equals negative 2. So x equals negative 1. And for our second solution, again, we're going to subtract 4 from both sides. So we get 2x equals negative 6. We divide by 2, x equals negative 3. So our two solutions are x equals negative 1, x equals negative 3. So again, we can use the rule that we have for exponents and radicals so that we can go interchangeably between them. We can also use that relationship to solve as well.